The trimming technique is one of my favorite inventive thinking skills because of its power and versatility. It can be used for so many different things: cost reduction, problem solving, patent circumvention, reducing your psychological inertia, and many other things. In a nutshell, trimming intentionally targets components in a product or steps in a process to eliminate or trim. And this nature of thinking forces thoughts along new lines that are unique and often lead to interesting ideas. So in this tutorial, you're going to learn several things. You're going to learn what trimming is, 5 problematic situations that trimming technique will help you with, and then you're going to learn 6 rules or directions to contemplate or think about to get ideas that you likely would never come up with conventional brainstorming. And you'll see several examples to support the concepts. So the easiest thing to trim, people will say, are those chrome caps. You can take those off, you can drill a hole through the handle and tie the ropes on the end. So it's easy to trim things. However, there's some things that seem impossible, like the rope. Very few people will try to trim the rope. Now, very creative people can actually figure out a way to trim the rope. Now, before we get into the details of how trimming works, I want to show you some quotes that embody the essence of what trimming is all about. First one here is, you know you've achieved perfection in design not when you have nothing more to add, but when you have nothing more you can take away. And in trimming, we're going to purposefully try to take things away from our systems, parts, steps, subsystems, and in some cases, the whole system. Here's another one. The third reason to trim is to reduce complexity. Okay, maybe for your end user, the product is too complex to use. Let's simplify it. Maybe for your manufacturing process, where in assembling it, it's a very complicated system and it's hard to assemble. So that's another reason. Now, those are the obvious reasons: cost, problematic components, or complexity. The 2 reasons to trim that aren't so obvious, number 4 here. So to do this trimming, there's actually 6 rules that we're going to show you. 6 directions to think around in order to figure out how to get rid of any part of any system or any step in any process. I know that sounds weird, but you can get rid of any part of any system and any step in any process if you think hard enough. And the fan is cooling a bulb. What's the bulb doing? That's projecting light or projecting an image. Could you trim the fan in this projector? Now, most people will say right off the bat, no, you can't do that. First rule, rule number 1. The function can be performed or delivered by other elements of the system or supersystem. Light or something else nearby, a supersystem element. If you can get one of those other elements to do a cooling job, yes, you can get rid of the fan. So now we're reformulating the problem. Now what we're saying is, how do we get one of these 6 things on this list here to do a cooling job? Or can we? So look at that list. Can you think of anything on that list that can do a cooling job? Now, when you first glance at it, nothing can do that. And the reason for that is you have what's called functional fixedness. Functional fixedness is a cognitive bias that limits a person to using an object only in the way that it's traditionally used. So you see a motor as only rotating something, or a power supply is only giving power to something, or a bracket is only holding something. Let me show you another example of rule number 1. A bicycle. And in this bicycle, you've got a shock absorber. This is a mountain bike. Could I get rid of a shock absorber on a mountain bike? That's a pretty important system. Well, rule number 1 is very distinct and shows you specifically what to think about. Rule number 4, the function does not need to exist. Here's another avenue of thought. So the fan cools the bulb. We're trying to get rid of the fan. And rule number 4 is saying you can get rid of the fan if you don't need to cool the bulb. So our whole line of thought now is around, is there any way to create a bulb that doesn't need cooling? And you might come back and say, well, awesome, we'll take it because we have a $4 fan system that we want to get rid of, a net savings of $2 on the system. So that's what we're trying to do, either get rid of the fan or improve the ideality of the cooling system. The next thing would be to cycle through the trimming suggestions. So here you see a suggestion. Is there a way that the bulb could somehow be able to cool itself or already be cooled?
Could the bulb not need to exist? If we could figure out how to get rid of the bulb, then there's no need to cool it. Think of a way to get by without the bulb.